Good morning, algebra class. Again, we are working on rules of logarithms this week. We're kind of building through all of the rules that will help us with solving some equations later, and just good basic information to have. These are really cool rules that help us to put logs together, take them apart when we need to, and just essentially deal with some of the trickier portions of a logarithm if we run into them. So today we are learning the power rule of logarithms, and by power what we mean is we have an exponent in it, okay? This is one of my favorite rules. It can feel kind of weird at first. It looks like, are you sure, Mrs. Tinker, that that is true? And I promise you it is. Again, we are not going through proofs of these. We are just giving them to you and practicing with them. So the power rule of logarithms, let me give you an example of that. Okay, if we have a log, let's do a log base 5 today. Okay, if we have a log base 5 of x squared, the power rule of logarithms tells me that that exponent 2 can be rewritten in front of the log. I can take that power, I can move it out front of my log. One of the coolest tricks with logarithms. So let me write that out for you. If I have log base A, I'm going to use x and n this time, okay? Then I can rewrite this as n times the log base A of x. One of the things I want to point out here while we're doing these, and this is our rule, one of the things that I really want to point out is that log, just like when we are using function notation, or if you are taking the square root of something, a log tells us that we are performing an action on whatever is coming next. Okay, this is not log times x. Okay, and that's something I haven't brought up. I kind of felt like that was something that you understood, but occasionally people get confused about that. Just like f of x is not f times x. This is the log of x. Okay, so we're performing an operation on there. Let's go ahead and take a look at this rule, and this time we're going to put a couple of our other rules together with it so we can kind of see that. Let's do a simple example first. If I have, let's not do y equals, let's say log of 7 to the x power. Okay, that power is a variable. That's okay. I have a single base here of my exponent. I have a single base. I can take that power and bring it out front, and that's the point. I can bring that out front. So I have x times log of 7, and probably already, maybe you can, maybe you can't, see how that would be useful in solving an equation, because you see now I can divide out. If I had an equation where I needed to solve for x, I could solve by dividing out the log of 7. This is a really useful power, or useful rule, the power rule. So let's take another one. This time let's combine it with something. If I have log of 2x squared, okay, I've just combined two rules, or I will need to combine two rules to expand this. Do you know which two? Obviously I have the power rule here because I have a power on that x, but I also have something multiplied to that power. Okay? I have an exponent, I have a base, I have a number in front. I can't just pull that 2 out front. And this is why we learned the product rule first. because first what I need to do is I need to separate this into the log of 2 plus the log of x squared. And now, because I have a single power here, I can pull the 2 out in front of that log. So this is going to be log of 2 plus 2 log of x. And I have expanded this into 2 logs where the power is now gone. It's in the front of the log. Okay? So if I want to expand, let's try another one. Let's say I have log of 5 over m cubed. Okay? Again, I can't bring that power out front. First of all, it's in the denominator, which I can't do that. I can't pull it out of the denominator. First, I have to separate this by using my quotient rule, which tells me that the log of 5 minus the log of m cubed is the same as this. It's expanded, it's rewritten. You see, now I have a power with a single base and nothing multiplied or divided around it, and I can now rewrite that. So I'm going to leave my log of 5 in the front, not touch it, it's fine, minus the log, oops, I forgot the 3, minus 3, I will bring that out front, log of m. And hopefully you can see how these are going together, how these properties work together. So first you have to separate these so that the power itself is a separate log before you can bring the exponent out front. So let me do one where we're going the opposite direction. Okay? If I have log of 7 plus 2 log of x, all right, then I know that I have the product rule happening here. This is log. When I see a plus, a sum, I know that I can rewrite this as 1 log multiplied together. So log of 7, what did I do wrong? I can't do that yet. That 2 is in my way. So I've got log of 7. So let's get rid of the 2. Let's put the 2 into the log this time. It's plus log of x squared. Now I can apply my product rule, and I will have log of 7x squared. Okay, so once you get to a place where you want to put them back together, you see a sum there, but you have that number in front, recognize that you need to get that 2 and change it into an exponent before you then multiply those together. Let's do another one of those. This time let's do a different base number, just to get you used to seeing that there are different base numbers. So log base 3 of, let's say, m minus 5 log base 3 of 2. Okay. Now I know I see a minus, that means I can use the quotient rule, but I also have that 5 there, and I can't use the quotient rule until going the other direction, until I get that 5 out of there. It has to be 2 logs, nothing in front of them, to combine them with the quotient rule. So I'm going to tackle that 5 first. I'm going to say log base 3 of m minus log base 3 of 2 to the 5th power. Now I could go ahead and calculate that out. Let's just leave it as a power right now. We have 2 logs subtracted. That means I'm going to apply the quotient rule this time. This will be my numerator, and this will be my denominator, and I can write this as 1 log. Log base 3, always remember, if you have a log base 3, they have to all have a log base 3. So it's log base 3 of m over 2 to the 5th. And if you wanted to simplify that, okay, it's 2 times 2 times 2 times 2 times 2 on the bottom. We can go ahead and simplify that. It is log base 3, I'm running out of space, of m over 32. Okay, so hopefully that helps, and I will see you soon.